Hey, Wagwan, it's Mr. Garfield here, and today we'll be looking at a CSEC mathematics question. All right, and I'm focusing on section 8, I believe, which is geometry and trigonometry. All right, and we'll be looking at a bearings question from the January 2020 past paper. Okay, so here we have our question. It says the diagram below not drawn to scale. Right, it says the diagram below not drawn to scale shows the route of a ship cruising from Palm City, P, to Quayton, Q, and then to Rivertown, R. The bearing of Q from P is 133 degrees, and the angle PQR is 56 degrees, as you can see from the diagram, right? Great. So it told us that about the diagram, and we have our questions here to the right, which says we have to calculate the angle W, right? Calculate the angle W here. Then determine the bearing of P from Q, and then we have to calculate the distance RP, right? So I put the sine rule here and the cosine rule here, all right? These are two formulas that we normally use when dealing with bearings questions, okay, in the trigonometry. So that is what we have there. And I took this from the formula sheet, right? Remember in the examination, you're going to be given a formula sheet. These two formulae are from the formula sheet. All right, so let's do part one, which says to calculate the angle W. Okay? Yes, so let us now calculate the value of W, right? The angle W. Now, if you look here, we have the angle W here, right? And in order to calculate the angle W, I need to add this angle, right? I need to add the angle W along with this angle here and that angle there, okay? So we know that the sum of angles, right, on a straight line is 180 degrees. So I can use that fact to calculate the angle W, right? But if you look carefully, I don't know what this angle is here, right? I don't know what that angle is. So it means that I need to find that angle first before I can actually find the angle W. All right, so I'm going to call it X. All right, I'm going to call it X. So how are we going to find angle X now? So let me just write down part one solution here. All right, so part one solution. How am I going to find the angle X? Well, if you look at that angle X and this angle here, right? If you look at that angle X and this angle, those angles are what we call co-interior angles, because when we add those angles, we are to get 180 degrees, right? So co-interior angles add up to 180 degrees. So I can say that X, the angle X plus 133 degrees is equal to 180 degrees. All right, and the reason why I can say that is because they are co-interior angles. All right, so I'm gonna add the 133 degrees with X, and the sum of that is to be 180 degrees. And the reason why is because they are co-interior angles. Right? You'd have met this, you'd have met these type of angles in lower school and possibly revisited the same angles in upper school. All right, so let us just calculate the value of X. So I'm now going to take this positive 133 degrees and subtract that from both sides of the equation, right? So if I subtract the left-hand side by 133 degrees, the 133 degrees will cancel out. All right, so we have 133 degrees minus 133 degrees plus x, and I now have 180 degrees minus 133 degrees. All right, so I'm subtracting 133 degrees from both sides of the equation. So what happens is that these two will cancel out, which will give me x remaining on the left-hand side of the equation, and that is equal to 180 degrees minus 133 degrees, which is 47 degrees, right? So that angle x there is 47 degrees. Great. So we're now trying to calculate the angle W. So I need to now add all of these three angles, right? So W plus 56 degrees plus x, right? Those are the angles on this straight line, and we know that the angles on a straight line sum up to 180 degrees. All right, let's do that now. So I'm now going to say that W plus 56 degrees plus x must be equal to 180 degrees. And the reason why is because angles on a straight line, add up to 180 degrees, right? Great. So we know what x is, right? X is 47 degrees. We've just calculated that. So I can now replace the x here as 47 degrees, and that all of that must be equal to 180 degrees. Great. So what is 56 degrees plus 47 degrees? That will give you 103 degrees, right? So I can now say that W plus 103 degrees equals 180 degrees. All right? So W plus 103 degrees equals 180 degrees. All right. Now I need W alone on this side of the equation. So I need to now subtract 103 degrees from both sides of the equation. Right? So what I have is W plus 103 degrees minus 103 degrees equals 180 degrees minus 103 degrees. Right? So I'm subtracting 103 degrees from both sides of the equation. And what happens is that those two will cancel out, which will give me W to be equal to 180 degrees minus 103 degrees. That is 77 degrees. Okay? So we have now completed the first part of the question here. It says to calculate the value of the angle W, right, which is 77 degrees. Great. Let's know the part 2 now, which says determine the bearing of P from Q. All right, determine the bearing of P from Q, from Q. All right, this is important, from Q. All right, so I'm going to highlight that. So let me just erase these highlight here. Great. So it says that we are to determine the bearing, right? Let's go back to it. Let's go back to it here. Yes, it says that we are to determine the bearing of P from Q. Now, what are they talking about? Right? What are they talking about? So it says from Q. All right, so we're measuring an angle from Q. Okay, so what they're asking us to calculate is this angle here, right? So we're starting at Q and we want to end up at P. So when you're measuring your angle or you're measuring a bearing, you have to do it in a clockwise direction. All right. So we're starting here, the bearing of Q, the bearing of P from Q, right? So from Q means that we're starting at Q, all right, and we're going to go right up here. All right. That is our bearing that they are asking us to calculate. Okay. Great. Now, how would you calculate that bearing now? How would you calculate that bearing? Well, I know that this angle, right? I know that all of this angle here, right? That'll be the angle on the straight line. Okay, all of that would be 180 degrees, right? I hope you agree with that. Okay, that is going to be 180 degrees. And to get the bearing now, I would need to add this 180 degrees to my angle W, right? So 180 degrees plus W plus 56 degrees, all right? So I would have to add those angles in order to get my bearing, okay? So let us just do part 2 here now. So we're looking at part 2 solution. All right, so it is 180 degrees plus my angle W plus 56 degrees. Okay, plus my 56 degrees. Okay, now this is going to be equal to, remember my angle W, we calculated that previously, that is 77 degrees. So it's 180 degrees plus 77 degrees plus 56 degrees. Okay, and if I add all of that now, right, if I add all of that, I will get 313 degrees. Okay, so that bearing there is 313 degrees. Great. So let me just erase this here. All right. Great. So we have now calculated the bearing of P from Q. Okay. And we got that to be 313 degrees. Now let us do the third part of the question, which says we are to calculate the distance RP. All right, RP. We're talking about this distance here. All right, this distance. That distance there. Okay. So yes, let us now calculate the distance RP. Okay. Now, if this angle here, the 56 degrees is angle Q, then the side opposite to that is going to be small q, right? Small q. That is going to be my side or the distance of RP, okay? And I have capital R here, right? So this angle here is R, okay? So it means that the side opposite to that is going to be small r. Okay, so small r in this case is the 210 kilometers. All right, and this angle here is my angle P, right? So if that is my angle P, then the side opposite to that is going to be small p. Okay, where P in this case is the 290 kilometers. Okay, now how am I going to find RP? That's my Q, right? How am I going to find Q? So it means that you're going to have to use one of these formulae, right? So you're going to have to use either the sine rule or the cosine rule. Okay, so depending on what you're given, all right, you know which rule to apply. So let's look at the sine rule, right? Let's look at the sine rule. We have A over sine A, right? So we don't really have A in this case. We have P, Q, and R. Let's look at Q, right? So if I'm using the sine rule, I can say that is small q divided by the sine of capital Q, right? Now, small q is what I'm trying to find, right? And I'm dividing that by the sine of capital Q, which is sine of 56 degrees. All right, that's no problem, right? So let me just write it down in case you're not understanding. So what I have is small q divided by the sine of big Q, right? Capital Q, which is 56 degrees. Okay, so we're just trying to figure out which one of these formulas we need to use. Okay, and that must be equal to B over sine B. We don't have B here, but we have P and R, right? So let's say we have P, right? So that is equal to small p divided by the sine of capital P, right? Now, if you look carefully, I know what small p is, right? Small p is 290 kilometers, right? So I can just replace that as 290 kilometers, right? Divided by the sine of capital P. But I don't know what the sine of capital P is. I don't know what this is, right? I don't know what that angle is. So I cannot use the sine rule in this case, right? I don't even know what the angle R is either. So I cannot use the sine rule, okay? So the sine rule is out. So it means that I will have to use the cosine rule, okay? So the cosine rule says a squared equals b squared plus c squared minus 2bc cos a, where a would be the side that you're trying to find, right? But what we're trying to find is RP, which is Q, right? We're trying to find small q. So I can just adjust this cosine rule formula to say Q squared, right? Because I want to find Q. So Q squared is equal to P squared plus R squared minus 2 times P times R times the cosine of the angle Q, right? You recognize that A is here, small a is here, and capital A is here. So if this is going to be small p, then this has to be capital Q in my formula, right? So in case you're not understanding, let me just write it down for you. All right, so we're now at part 3. So part 3 solution. So I'm gonna have my cosine rule, all right, which is gonna be Q squared, which is equal to P squared plus R squared minus 2PR multiplied by the cosine of my angle Q. Okay, good. I want to try and find Q, which is the PR that they asked us for. All right, so Q squared is going to be equal to P squared. Let's just look at the diagram. P in this case, small p is the 290 kilometers, and R is the 210 kilometers. All right, so if I want p squared, then that is going to be 290 squared plus I want r squared. R is 210, that's 210 squared, minus 2 times p times r. So p is 290 multiplied by r, that's 210, multiplied by the cosine, right? Multiplied by the cosine of my angle Q. Let's go back to the diagram here. My angle Q here is this angle, okay, that angle there, which is 56 degrees. Okay, so angle Q is 56 degrees. So I'm gonna have the cosine of 56 degrees. All right, so all I have to do now is just simplify and solve for Q. So Q squared is equal to 290 squared plus 210 squared. I can just put that in my calculator. And if I do that, I will get 128,200. All right, minus 2 multiplied by 290 multiplied by 210, right? If you put that into your calculator, you will get 121,800. All right, and remember that we're multiplying that by the cosine of 56 degrees. Good. So I'm just going to put all of this now into my calculator. And if I do that, I will get 600,000 90.30436. Right? Those are all the digits in my calculator. Okay? So I now have q squared being equal to that number there on the right hand side. So if I want q, it means that I would have to take the square root on both sides of the equation. All right, so q is equal to the positive root. All right, so it's going to be the positive root of 60090.30436. Okay, good. That is what we have. So q is equal to, if you should put that into your calculator, right, I will get 245.13 to 2 decimal places. Okay, to 2 decimal places. Great. And that is my answer for the third part of the question, which says that we are to calculate the distance RP. Okay, so that is the solution for this bearings problem from the January 2020 past paper. All right, I hope it was helpful. If it was, please ensure to like up the video and comment down below. Okay, I am Mr. Garth Reed, student ambassador in the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.